So that means e to the x squared y must be the integral for x e to the x squared dx plus some constant. What is the integral of 4x e to the x squared? Well, I really look at this as 2x e to the x squared times 2. So this is 2 e to the x squared plus c. You could quickly check, what's the derivative of 2e to the x squared? It is e to the 2x squared. It is 2e to the x squared times the derivative of x squared, which is 2x, times the 2, which is that. So therefore, y is 2 plus c e to the minus x squared. So here's two examples. They illustrate that when I have a linear equation, I want to multiply by something so that the left side becomes a derivative of the product. And that's what we're doing. Okay? You identify an equation as linear. That's how you solve it. Okay. Where did I get e to the x squared? Where did I get e to the minus 2x? Let me show you. Here we have a linear equation, standard form. A mistake that people make often is they identify the equation as linear, but they do not write it in standard form. I have some examples to show you in a second. More examples. What we multiply by, that thing we want to multiply by, is e to the integral of p. That's what we want to multiply by. E to the integral of that coefficient. If we go back to this example here, you see p of x is 2x. I want to multiply by e to the integral of p, which is e to the integral 2x dx, which is e to the x squared. That's where I got the e to the x squared. Okay, so you multiply by e to the integral p. The equation now looks like this. And the left side is the derivative of e to the integral p times y. You can check. This is a product. First function, derivative second, which is this, plus the second function, y. The derivative of e to the integral p is e to the integral p times the derivative of integral p, which is just p. That's the fundamental theorem of calculus, right? The derivative of the integral of p is just p. The derivative of the integral is the integrator. Okay? So we have this. That is to say, e to the integral p times y prime is this expression on the right. Just integrate. And then solve for y. And so here's the general solution. Now, there's a lot of symbols there. I would not even recommend memorizing that. Just remember what you do. That's, in my mind, easier than trying to remember this last formula. But this here is the general solution. So that's first order linear. Shall we go on to separable? I'll show you how to do that. Just look at an application. It'll be 3 o'clock. And I'm ready to go to chapter 3. That may be a little fast. Okay. This thing that we multiply by is called an integrating factor. That's what it's called. Okay. So now we want to look at some examples. So I look at that. And I realize that I can put this in, this is not in standard form. Okay? So I look at that equation, and I realize that I can write it as y prime plus p of x times y equal q of x. Right? And this is your responsibility. To be able to look at an equation and identify it. Okay? This is a linear equation. but it's not in standard form. Right? I can see in my head that if I divide all the way through by x, I get y prime plus 3 over xy is log x over x cubed. And that's linear. This here is p of x, and this here is q of x. So it's linear. Now I know how to solve a linear equation. We multiply by e to the integral of p, which is e to the 3 interval, 3 over x dx, which is e to the 3 ln x, which is e to the ln x cubed, which is x cubed. That's why I put these kind of problems on EMCF 1 and 2. Right? You have to know the properties of exponential and log functions. So I multiply through by x cubed right here. Where do people make mistakes? They say, well, look, I realize this is linear. So I'm going to multiply through by e to the integral of 3. No, right? No. You have to write the equation in standard form. Then multiply through by e to the integral p. Okay, so we multiply through by x cubed. Right here, we get x cubed. And by the way, some people will make a mistake of multiplying here by x cubed. I take my equation, standard form, integrating factor, multiply the standard form, in this case by x cubed y prime, 3x squared y is ln x. The left side is x cubed y prime is ln x. You always pause here. I used to do this when I took this course. I would pause here just to make sure. First derivative second is this term. Second, y, derivative of x cubed, 3x squared. So x cubed y prime is log x. X cubed y, I'm integrating now, is the integral ln x dx, which you all remember is ln x minus x plus c. Maybe you don't remember that the integral of log x is x log x minus x. Maybe none of you remember that. No reason why you should. How would I integrate log x? How do you integrate log x? You say by parts. You integrate it by parts. Right? That's why I had some problems like that on EMCF 1 and 2. This stuff comes up, right? Intuitively, to solve a differential equation, you have to integrate it. Okay? To solve a first order equation, you're going to have to integrate once. Heaven only knows what it is you're going to have to integrate, but you've all had calculus too, so you all know how to integrate the standard elementary functions. All right. So, can we see here that what we have is x cubed y is x ln x minus x plus c. Divide by x cubed, and we get that. There's the general solution. So first order equation, not hard to solve. You know, your only hurdle is doing whatever the integration is. Yes?
Could you explain again the part where it's the parentheses, x cubed y, and then the right?
Okay. So I multiplied by x cubed, right? write it down again. We had y prime plus 3 over xy is ln x over x cubed, right? I multiply by e to the integral 3 over x dx. E to the integral of the coefficient of y. This is e to the 3 ln x, which is e to the ln x cubed, which is x cubed. Multiply by. So what we get is x cubed y prime plus, now x cubed times 3 over x, I hope you see, is 3x squared, right? 1x cancels y equal ln x. X cubed times ln x over x cubed is ln x. Now this is your question, I guess. I write down this is x cubed y prime. Why? This is a product. How do you differentiate a product? First, derivative second. That's that. Plus, second function, derivative first function. The derivative of x cubed is 3x squared. So what I've written down is correct. So this is ln x. Now, this equation says, look, if I gave you the